This lesson focused on how to solve absolute value equations and absolute value inequalities. The first thing that we have to remember about absolute value is that absolute value is the distance away from zero on a number line. So what you have to remember is that there are two directions away from zero that we can go on a number line, positive or negative. So if we had the absolute value of x equals 3, this is an actual equation here because we have a variable and we need to solve for the variable. So if this was the absolute value of x equals 3, then we know that x, the solution is x equals -3 or 3. Why? Because we can go 1, 2, 3 units to the right, positive, away from 0, or we can go 1, 2, 3 units to the left, negative, away from 0. Both of these are 3 units away from 0, and because absolute value is the distance from 0, we know that these are our solutions. So remember, when you're solving an absolute value equation or inequality, remember that there will always be two solutions to the equation. So let's look at an example that they gave us. The first one was the absolute value of x plus 5 equals 11. Now we're going to solve this equation just like we would solve any other equation. We want to isolate the variable, in this case x on one side, and the constant on the other. So right now we have our variable and a constant on this side and just a constant on the other. So what do we need to do? We need to get rid of this 5. How do we do that? We subtract it. So we subtract 5 from one side, and what we do to one side we have to do to the other. So the absolute value of x plus 5 minus 5 leaves us with the absolute value of x, and then 11 minus 5 equals 6. So now we know that the absolute value of x is 6. So if the absolute value of x is 6, then we know that x equals 6 or -6. Because again, we can go either direction on the number line, positive or negative. Okay? It gave us a second example, this one a little bit more challenging, and that equation was 4 equals 3 times the absolute value of w minus 2. So again, we're going to solve this just like we would solve any other equation. We want to isolate the variable on one side, the constant on the other. So what this says is 3 times the absolute value of w minus 2. So our first step, we're going to add 2. Plus 2, plus 2, 6 equals 3 times the absolute value of w. Okay? Now we need to get rid of this 3. How are we going to do that? We're going to divide. Divide both sides by 3. We know now that 2 equals the absolute value of w. So what does that mean for w? We know that it means w equals 2 or -2. Now let's look at solving when the variable expression is within the absolute value symbol. So when the expression is within the symbol, then we know that the expression can either be positive or negative. And what that means is that we're going to have two equations to solve. So the example they gave you was 2p plus 5 equals 11. So what this is saying is the absolute value of 2p plus 5 equals 11. And another way to say that is 2p plus 5, we're going to have two solutions. Each solution is going to be 11 units away from 0. So how do we do that? We need to set 2p plus 5 equal to 11 and equal to -11. So 2p plus 5 equals 11, and 2p plus 5 equals -11. Okay, this is going to allow us to solve for both values of p. So here we need to get rid of the 5, minus 5, minus 5. Now we know 2p equals 6. Get rid of the 2. How do we do that? Divide by 2, divide by 2, divide by 2. p equals 3. And then on this side, we have negative 11. Again, we need to get rid of the 5, so we subtract 5. And when you subtract 5 from a negative, or subtract a number from a negative, you're going to have a higher negative. Negative 11 minus negative 5 is negative 16. So now we have 2p equals negative 16. Divide by 2, divide by 2. And now we have p equals negative 8. And these are our two solutions. So again, when you have an expression within the absolute value symbol, you must set your equation equal to the positive and negative form of that equation. All right, let's talk about absolute value and inequalities. Now remember, when you solve an inequality, the solution that you're looking for is anything that makes the statement of the inequality true. So if we look at this one, the absolute value of n minus 1 is less than 3. What that is saying is that the absolute value of any solution to n minus 1 is going to be less than 3. And over here, the absolute value of n minus 1 is greater than 3. So the solution, any solution to n that you can plug in, is going to be greater than 3. If you plug in a solution to n and it's less than 3, that does not make the inequality true, and that would not be a solution for this inequality. So how do we solve inequalities? The nice thing is there's an easy way to do it for both of these. If we look at any inequality in which the inequality is less than the constant, which is over here, and this constant is greater than 0, which this is, then there's an easy way to set it up, and it looks like this. Come over here and set it up just like you see up here. So n minus 1 is less than 3. The only thing you need to add is the negative value of this constant, which is going to be less than n minus 1. Okay? So what this inequality here says is negative 3 is less than n minus 1, which is less than 3. Now we can solve this inequality very easily. How do we do that? We get rid of our constant here. Okay? We want n by itself. How do we do that? Well, we need to add 1. And the way we do that is we add it to both sides. So we add 1 over here, and we add 1 over here. And now what we have is the solution to our inequality. Negative 3 plus 1 is negative 2. N and this is now our solution to this absolute value inequality up here. Negative 2 is less than n, which is less than 4. Or another way to say it is n is less than negative 2 and less than 4. And if we look up at the number line, we see negative 2, 4. We've got our open-ended dots. Why? Because this is an inequality. It's not equal, less than or equal to. It's just less than. So the answer is any value of n that is less than negative 2 and less than 4. Now, how do we do it over here when the solution is greater than? Well, we need to set the equation equal to the positive and negative value. Okay? How do we do that? N minus 1 is greater than 3. And n minus 1. Now, when you set it equal to the negative value, you have to flip your inequality sign. Okay? So here we have n minus 1 is greater than 3, but now we're going to set it equal to the negative value. We have to flip our inequality sign. So now n minus 1 is greater than 3, and n minus 1 is less than negative 3. And again, any number less than negative 3 is going to send us farther away from 0. And then all you need to do is solve just like we did over here. So we're going to add 1 to both sides. Now we have n is greater than 4 and n is less than -2. And these are our two solutions to an inequality. Because remember, any absolute value equation is going to have two solutions. We talked about that earlier. And if we look at the number line, we see if we plug in 4 minus 1 is what? 3. Is that greater than 3? No. So again, we have our open-ended dot, and we go farther away from 0. 5, let's plug in 5. 5 minus 1 is what? 4. Is that greater than 3? Absolutely. Over here, -2. If we plug that in, -2 minus 1 is -3. Is that greater than 3? No, because that's still 3 units away. Okay, and we want greater than. So let's look at -3. -3 minus 1 is -4, or 4 units away. Is that greater than 3? Yes. So again, if you have an inequality, an absolute value inequality with the less than symbol, you set it up this way. If it's greater than, you set it up this way. One more note. Absolute value is the distance away from 0. With that said, if you have an absolute value equation that is set equal to a negative number, you automatically know that there is no solution to that equation. Why? Because you cannot be negative units away from 0. Now, your absolute value number could be, let's say, 6. What that means is you are 6 units away from 0 positive, which is 6, or you are 6 units away from 0 negative, which is -6. But the answer is still 6. The absolute value is 6. So again, if you have an absolute value equation and it's set equal to a negative number, you automatically know, hey, there's no solution to that equation.
In the second lesson, we talked about graphing absolute value equations, and specifically about translating those absolute value graphs vertically, horizontally, or both. One of the things you need to remember is that whenever you translate a graph, it maintains its shape. So you are moving it along the x or y axis, but the shape will remain the same. So the shape of an absolute value equation is always a v. So if we look at the equation y equals the absolute value of x, when we graph that, we see that it's a v, and the vertex is at the origin, 0, 0. We talked about translating it vertically and horizontally. So let's look at vertically first. The way that you translate an absolute value graph vertically is by adding or subtracting a constant outside of the absolute value markers. So what does that mean? So let's talk about translating this graph up 2 units. So what would that look like? Y equals the absolute value of x, and then we're going to add 2. And we see that the graph maintains its shape, and we've got our v there. Our point of origin is now 0, 2 instead of 0, 0. We've translated this graph up vertically 2 units. What would it look like to translate it down 3 units? Y equals the absolute value of x minus 3. Now we've got our 3 graphs here. We've translated them vertically. We started with y equals absolute value of x. To translate it up vertically, we add a constant. To translate it down vertically, we subtract a constant. And that's how you translate an absolute value graph up or down. How do we translate it horizontally? Well, for that, you're going to add a constant within the absolute value markings. What does that look like? So let's get rid of our 2 that we translated and start again with just the absolute y equals the absolute value of x. If we wanted to translate that graph 2 units to the right, how do we do that? Y equals the absolute value. Now we're going to put our constant in the absolute value markers. And so in order to translate our graph right, we have to subtract units. So if we're translating it right 2 units, it's going to be y equals absolute value of x minus 2. And you can see, again, we've maintained our shape and we've translated it 2 units to the right. Well, what if we want to translate it 5 units to the left? Again, y equals the absolute value of x. Now to translate it left, we need to add a constant. If we want to translate it 5 units to the left, we're going to add 5, and boom, there we are. We've translated 5 units to the left. You've got to remember, in order to move right, you subtract. In order to move left, you add. Why is that? Well, because we're translating from 0, 0. So in order for the solution, or in order for y to be 0, in this case, x needs to be -5. -5 plus 5 is 0. Or up here, x needs to be 2, because 2 minus 2 is 0. So if we wanted to translate the graph here of y equals the absolute value of x, let's say we want to translate it 3 units to the right and 3 units up. What would that look like? Well, we need to subtract 3 in the marker, and we need to add 3 outside of it. And there we go. Our vertex is now at 3, 3. But again, we've maintained that V shape. So again, if you want to translate an absolute value equation on a graph vertically, you add or subtract a constant outside of the absolute value marker. If you want to translate it right, you subtract a constant within the absolute value marker. If you want to move it left, you add a constant within the absolute value marker.